Okay, here we go. Unit 7, Lesson 2. The big concept is that an inscribed angle equals 1/2 the central angle, its central angle. So in other words, well, we'll get there. Okay, the measure of angle AOB is 56 degrees. What is the measure of angle ACB? Let me think here. Oh, I know how you could get this. Because the central angle is 56, that means this arc is also 56. Here's the arc from A to B. Right? So therefore, this angle is 1/2 of this. Kind of cool, huh? So you can also use arcs too, which is pretty cool. So if the arc's 56, then this is, what, 28? So the measure of angle ACB, this one, is 28 degrees. All right. Angle ACB. Okay. Explain the difference between central and inscribed angles. So I'm going to use a picture to do that. Hopefully this works. Okay, so we got a circle, right? Let's call this point X, Y, and then let's just pick a point over here and call it Z. This is the center. All right, so I'm going to use dashed lines for the central angle. Okay, XCY, so angle XCY is known as a central angle. What's a central angle? Central angle is whose vertex is in the center of a circle. So center of the circle, right? Inscribed angle is right here. So that would be angle XZY. Is an inscribed angle. And inscribed angle equals 1/2 its central angle. So whatever this is, this will be 1/2 of it. So central and inscribed. Now let's go to the definition of inscribed angle. An angle formed by two chords that share an endpoint. Two chords that share an endpoint. That's the angle formed by two chords, CB in CA, and they share C. All right, cool. So ACB is an inscribed angle. Or XZY, inscribed angle. XCY is a central angle. And then this one's gonna be half of this. All right, what is the measure of the arc from A to B? So we gotta figure out what this is right here. Now this is kind of cool. Anytime you have a diameter and then you pick any point in between them, it's always gonna form a 90-degree angle. Watch this. I know this is 90. Now, this is a principle I didn't really teach you, and I still remember it, luckily, even though I never covered this lesson, but it's pretty cool. I saw this teacher, I think his name's Henry Wu. They regularly call him like one of the best teachers ever, but he has a really cool video about this. But anyway, any point like in between the diameter is gonna form like a 90-degree angle. Let me do one more for you. Let's look at this point right here. Watch this, it's pretty cool. I'll use that. Different color. But yeah, any point in between the endpoints of the diameter, if you build a triangle, it forms a 90-degree angle. So there's right triangles like everywhere within circles. Infinite number of right triangles. Isn't that cool? And it has a lot to do with like velocity and stuff. Okay, so we know this is 90, which means this has to be 50. Why? Because 90 plus 40 plus 50 equals 180. So it's, oh, and I made a mistake. Here to here will be 50 degrees. Wait a second. What am I doing wrong? What is the measure of arc from A to B that does not pass through C? What am I doing wrong? Let's see. Oh, I know this is 100. Whoops. Gosh, almost messed up. Because this is 50. This has to be 100. Whew, almost made a mistake. What do you know? All right. Find the values of X, Y, and Z. X is 50, meaning Y is 130, and Z is 130. Okay, match the vocabulary term with the label. A chord that is not a diameter. Y. Diameter, X. Radius, W. Central angle, M. Easy. Easy. Okay, 6. 2 more. We're done for the year. Okay, triangle ABC is -4, 0, 212, and 12, 0. What is the point of intersection of its medians? All right. I think it's going to be... No, I'm not even going to try that again. Let me just create this. And this is a problem that you don't have to do because we didn't cover it. Unit 6, lesson 16. But I do want to figure it out. Okay. So we got to go pretty small on this. 12, 0. All right. all right. I'm gonna go old school, use the graph to figure this one out. Alrighty. It's gonna go off the grid. Whoa. Okay. Yikes. There's an easier way to just use the coordinates, but we'll see how this goes. Do it my way and we'll figure it out. Okay, so we got triangle ABC is vertices at -4, 0. -2, 12, which goes off the grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. -2, 12 is like up here. I'm gonna start drawing it. It's 11, -2, right there, yep. -2, 12 is like right there, okay. And then 12, 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're like up here. Okay, so here's our triangle. What's the midpoint of the intersection of the medians? Alrighty. So if this is -2, 12, the x-coordinate, the median is going to be, since this distance is 2 plus 12, that's 14. Now we got to go 7. So 1, 2, 1, 2, 3, 4, 5. So the median of this one is right here. Whew. Let's look at this one. -4, -2. So it's the median of this one's gonna be like right there, roughly. And the median of this one, 4 plus 12 is 16, so we gotta go 8 is gonna be right there. So let's draw these. Medians, find out where they intersect. Graph paper would have been really helpful on this one. Oh well. I think I know where it's gonna be, but we'll see. Median goes from the midpoint to a vertex. So our median's right here. Which looks to be 2, 1, 2, 3, 4. 2, 4. Boom, there it is. Oh, got through it. What do you know? All right. The rule xy to y -x takes a line to a perpendicular line. Select another rule that takes a line to a perpendicular line. Okay. I think it's C. But basically you gotta get the slopes. So in all these, we're gonna call these x1, y1, x2, y2, and then we're gonna use this formula. M equals y2 minus y1 over x2 minus x1. So let's do the first one. That'll be negative x minus y over negative y minus x. So that equals negative x plus y over negative x plus y. It just took a -1 out of each. And then I know y plus x is the same as x plus y, so these cancel. So you're gonna have +1. Now remember, the product of perpendicular lines always equals -1. Okay, let's look at the second one. M will equal y2, 2x, minus y over 2y minus x. Let's look at this one. M equals y2, 4x minus y over -4y minus x. And then let's look at this one. M equals -4 minus y over 0.25y minus x. Okay. All right. How are we gonna figure this out? I think I'm gonna go a different route. I'm gonna do this. I did this last time and it worked. I gotta brush up on that lesson. It's been a while. Oh well. We're gonna use the y equals x line. So the y equals x line is pretty simple. Another trick you can use. All right, so the y equals x line is this line right here. Is y equals x. Just for good measure, I like to do 2 points. We got 1, 1, 2, 2. Okay, first one. Negative y, negative x. So here's the first one they're asking. xy to negative y negative x. This might be our one here. Okay, so 1, 1 would go to negative 1, negative 1. So it'd go right here, right? 2, 2 would go to negative 2, negative 2. Right here. It would just be the same line. So the first one's out. Okay, what about xy to 2y to x? That might be our one. Let's see. So 1, 1 would go to 2, 2. Okay. 2, 2 would go to 4, 4. That also would be the same line. So what about the third one? This is the one I initially thought was correct. Negative 4y, 4x. All right, so 1, 1. So 1 comma 1. The y coordinate would become negative 4. Okay, so 1, 1 go to negative 4. The x would become the y. 4 times the x, negative 4, 4. Okay. Negative 4, 1, 2, 3, 4 would be right here. This is the one we want, I can tell. All right, let's look at 2, 2. 2, 2 would become what? The x becomes 4 times as big, and it becomes the y. The y becomes the x, and it's multiplied by negative 4. So negative 8, 8. It's going to be up here somewhere. Yeah, it's this one. So your answer C. Somehow, some way we got there. These are perpendicular. Negative 1, 2, 3, 4, 5, 6, 7, 8. It's gonna be like right here. So yeah, your answer is C. I gotta brush up on Unit 6, Lesson 11, which we didn't cover. So let's just look at it. Slope of opposite reciprocals. They have opposite signs, product of those slopes. Use this factor equations. You need to know that these lines have opposite reciprocal slopes. So use the y equals x line if you're stuck like I was. Because by computing this rule, you can use the y equals x line to get the new coordinates. And then this would be like x1, y1. This would be x2, y2. Sorry. These would be x1, comma y1. These would be x2, comma y2. So these ones and these ones. So y2 minus y1, 2 minus 1. x2 minus x1, 2 minus 1. G equals 1 over 1. G equals 1. Let's look at this one. Y2, 8 minus 4 over negative 8 minus negative 4. 8 minus 4 is 4. Negative 8 plus 4 is negative 4. And that equals negative 1. Ooh-wee. 1 and -1 are opposite reciprocals. Why? Because 1's the same as 1 over 1. -1's the same as -1 over 1. So switched and became negative. Woo! Figured it out. What do you know? All right, so there you go. My last one was a doozy, but that was a good way to end it. Final 2 baseball cards are Kobe and MJ. Yeah, MJ's the GOAT. I saw Kobe. I was in the building for Game 7 against the Celtics in 2010. What are the odds of that? Anyway, that's it for the year. We got through Unit 7, Lesson 2. My goal for 25-26, the year 25-26, is get through Unit 7 and do Unit 8 first 2 lessons at least. So do a whole new unit next year. That'll involve a lot of self-directed learning with videos, because I didn't miss a day this year. I pride myself on that. And if we double up the lessons, that's how we get more. And the only way to do that is with video lessons for homework. That's my goal for next year, geometry. So double up the lessons. But anyways, have a good one. Have a good summer. And see you.